Let's do a hypothesis test in multiple regression. So we want to determine whether, as a collective, the coefficient of determination value arose as a matter of chance at the 5% significance level and the 1% significance level. So we're going to use some information from our t-tables. But first we need to set our hypothesis. So to do that, we'll set our hypothesis as our slope for our first variable equals our slope for our second variable, which equals 0. And our second one is that not all Okay, so what does this mean? Basically, that we're setting a hypothesis that we want to know if our slopes actually have any impact on our equation. So if they don't have any impact, they would equal 0. But if they do have any impact on our equation, they would not equal 0. They would be what we've set our variables at. So this is just our way to test to make sure that it's not just chance, because we may have gotten our probability, our formula, just through the chance of the different information. But if chance is not involved, then we should be able to reject this null hypothesis. So now what we need to do is check to see if our f value is going to be higher than what we can determine from our f table. So let's have a quick look at our Anova table. Now they've given us our f value here of 34.49. So this work has already been done for us. We don't need to calculate it when we use it in Microsoft Excel. And so we have an f value of 34.49. And now we need to see if it's going to exceed a critical value. So we need to go to our f table and look up our critical value. So first we need to determine our degrees of freedom. We can do that. Let's go and have a look at our Anova table again. As we can see here, our regression degree of freedom is 2 and our residual degree of freedom is 2. So we have a numerator degree of freedom of 2 and a denominator degree of freedom of 2. And we can have a look at our f table. Our f table here shows degree of freedom for our numerator 2 and denominator 2 brings us to 19. Now this is f table for 5% significance. That's the first one we're working through. So the f value from the table is 19. So as you can see here, our f value that are from our Anova table is greater than our critical f value of 19. So therefore, we can reject our null hypothesis, and we can state that the results did not arise from a matter of chance, that the data actually directly caused us to receive these values. Or at least there's not enough evidence to reject that. Let's have a look from a 1% significance level. So our f value is going to remain the same, but we need to determine if the critical value is higher or lower. So if it's higher than our critical value, we're going to reject our null hypothesis. If it's lower than our critical value, we are going to not reject it. We're going to not have enough evidence to reject it. So if we head into our F distribution tables here and find our 1% significance, degree of freedom 2, degree of freedom 2, and we have a critical F value of 99. So as you can see, our 99 F value is larger than our F value found on from our Anova table for our information. So we can accept the null hypothesis now. We do not have enough evidence to reject the null hypothesis. So at a 1% significance level, we can say that essentially that our variables did come up from the slopes of B did come from a matter of chance, and that they didn't come from the information. So at a 1% significance level, we wouldn't be able to use this information. Now, one thing you can do to try to make it work with the significance level of 1%, 5 observations is a pretty small sample size. Larger sample sizes drastically improve the likelihood if there is a correlation there. So if a sample size of 5 is going to allow your F value to exceed the critical value, there would have to be a massive correlation for a sample size of so small to work. So this is not saying that the variables aren't going to affect our formula. All it's just saying at 1%, we can't state, we don't have the evidence to reject that they don't. So in this scenario, we would tell the instructor just to go back and take a larger sample size if they want to be absolutely certain.